So we're going to work a little bit more with our rational functions today. We're going to get through all of the pieces that we need on them, and then we'll have a little bit of time to ask questions and work on the review and stuff. Tomorrow we'll do the quiz, and then we'll start with the graphing. Okay, so we're going to get all of our pieces. Then we'll work on stuff, and then tomorrow we'll start graphing. So tomorrow and Monday we'll be graphing. So just sharing the plan. So we're going to talk about our asymptotes today. We're going to have lots of different ways that we're going to find asymptotes on these, because these kinds of graphs have kind of a lot of asymptotes. So our first kind of asymptote is going to be our vertical asymptotes. They're one of the easier ones to find. And what that is where our denominator equals 0. There we go. Nope. That setting. There we go. My brain is not braining well today. So what we're going to do here is we are going to factor, and in this case we're going to factor both numerator and denominator, because we want to make sure that we don't have any discontinuities anywhere. If it's a discontinuity, it's not an asymptote. So we got to double check that. So remember, our discontinuities, that's where we have one that cancels out. So we're going to start by just factoring everything, if we can. If we can't factor it, we can't factor it, and that's a thing, and that's okay. But it's important that we check. So, looking at our numerator, could we factor it? Yeah. Because that would be one of those multiplies to make negative 28, adds to be 3. What pair of numbers will do that? 7 and negative 4. You're doing the bottom one.
My bad.
I was going to say, I know that's the right answer, but it's not for this piece. So be careful when we're doing this, because we have that a value of 4. I'm going to do this one factoring by grouping, where we have our 4x squared. I'm going to take my minus 4x plus 7x minus 7. I'm doing factoring by grouping here. So we've got what are our factors that we're going to get? 4x not 4x plus 7.
Oh, minus 7.
Not minus 7. Oh, yes, sorry, you're right, sorry. My bad. 4x plus 7 and x, what's left over? Minus 1. We good? Yeah, the denominator is a lot easier to spot, because that one does not have our a value. All we need to do is find our pair that multiplies to be 15, adds to be 8. We have our positive 5 and our positive 3. So x plus 5 and x plus 3. So it's important that we check to see if we have discontinuities, because again, a discontinuity will not give us an asymptote. But do we have anything that's going to give us a discontinuity here? No. So we're going to find our vertical asymptotes by setting each of the factors of our denominator equal to 0. So it's like the roots, but of the denominator piece. So only the denominator. Because that's where we run into problems, because that would make our denominator 0, which we can't do that. We can't divide by 0. So when our denominator is 0, we have an asymptote. So where are our asymptotes going to be? I need a different color. There we go. What is the root of x plus 5? Negative 5. When x equals negative 5, we have a problem. Because if x is negative 5, I have a 0 in the denominator.
Oh.
Okay. What is my other problem point in my denominator? Negative 3.
I have a question.
Yes, dear?
What do we have in the pink parentheses right here? Where did we pull that from?
This bit down here? I took this guy, and my 7 and my minus 4. I just switched their spots over here.
Oh, okay.
I was just factoring it by grouping because my brain was not braining well, and I was not able to do it in my head. So I was just writing it down because I was not processing correctly. My brain is in a brain mood today. So what these are, what's up? These are our asymptotes. And what these are is these are our vertical asymptotes. So when we are graphing these, just as a reminder on what our asymptotes are, that's when we have those dashed lines. So like our negative 5 will be like this, and our negative 3 will be like this. So this one's going to have 2 vertical asymptotes, which we will have, and we will practice what those look like. But on these graphs, what it's mostly going to be is we're going to have pieces that get real close to our asymptotes wherever those are. So we're going to have vertical discontinuities, we're going to have infinite discontinuities, we're going to have pieces all over the place. And we don't have enough information right now to finish the graph and figure out where any of these other pieces are, but we will. We'll do that tomorrow. Okay, but that's what those are. So we find our vertical asymptotes when our denominator equals 0. Okay? Yes, sir.
Can the lines ever go in the middle of that part?
Yes, they will, and we'll practice with that tomorrow. Whenever and they're gonna, we're gonna have squiggles, they're gonna be S-shaped, they could be U-shaped. We'll practice with that. I promise I will show you. But especially when we have 2 asymptotes like this, we will have pieces in the middle. Okay. So we have vertical asymptotes, but then we also have another kind of asymptote. We're going to have what we're calling our end behavior asymptotes, because we have a couple of options on it. We may wind up with a horizontal asymptote, which is what we did a lot of in Algebra 2, where we had just sideways lines. Or we may wind up with something called a slant asymptote, or an oblique asymptote. Well, oblique is like on the side. It's the slanty muscles right here is the obliques, because they're slanted. So that's where oblique. So I'm 90% sure. I'm not like anatomy. I was like, it's the slanty ones right there. So what I'm going to do is I'm going to give us our list of options here, and then we're going to go practice and identify these pieces. So when we have it in our P of X over Q of X form, so it has 2 different functions. If the degree of P of X is smaller than the degree of Q of X, so we're looking at our degrees, is how we can tell about our asymptotes. If our degree of P is smaller than the degree of Q. So example of that would be if I have X over X squared. The degree of P is 1. The degree of Q is 2. So my degree on the top is smaller than the degree of the bottom. This will have a horizontal asymptote. At y equals 0. Only option. No matter what the functions are, if the degree of the top is smaller than the degree of the bottom, our asymptote is at 0. For our horizontal asymptote, it's 0. If the degree of the top is equal to the degree of the bottom. So if the degree, which I'm just going to put deg, of P is equal to the degree of Q. So let's say we have X over X, or X squared over X squared, things like that. They're equal. They have the same degree. We're going to have a horizontal asymptote. So it's going to be straight sideways. At the ratio of our leading coefficients. So I'm going to write this as y equals the leading coefficient of P and the leading coefficient of Q. So for example, I'm going to put an example over to the right. If I have 2x squared over x squared, they have that same degree. I take the leading coefficient of the top, 2, and our leading coefficient of the bottom, 1. So this would have a horizontal asymptote at y equals 2. 2 over 1 is 2. So it's the ratio of our leading coefficients. And there's a way to make both of those be the same thought process, which I'll show you when we look at them. But I'm going to start by writing it out like this. And then our last option is if the degree of P is greater than the degree of Q. So if our degree of P is greater than the degree of Q, that's when we get our obliques, our slant or our oblique asymptote. And I genuinely do not care which one you call it. I just give you both words just in case we see it written in either way. And the way we're going to find out our slant or our oblique asymptote is we're going to have to do some division. And it's our, when we did like our P of x divided by our f of x and we got our q and our r, it would be our q. But they already used here, so it would be our dividend when we do our division. It's the remaining polynomial after division, which I promise I will show you because I know that sounds overcomplicated. But I'm just finding words that we can like write down for it so we have it. So it's the remaining polynomial, usually going to be linear. For us, it's only going to be linear. After division. So when our numerator has a higher degree, that's when we have the most work. So if the degree on the top is smaller, our asymptote's 0. If the degree are equal, it's the ratio of our leading coefficients. And if the degree on the top is bigger, we have to do some division. But this is going to give us our end behavior asymptotes. It tells us what happens as our ends with our arrows, and it shows us kind of what's happening in the middle. So it's an important piece. It's a super important piece. So what we're going to do is we're going to start by practicing these. And I'm going to give you a second to write it down. And my equations are like super low to the bottom, and I don't think it's going to let me move them up. I'm just trying real quick. It's not going to let me do it. But they're just really close to the bottom. Okay. It's not going to let me move them. So they're like in the middle, but at the bottom, but like, eh. All right. It's just being grumpy. All right. I was just trying to get things to move up. So we have here our first function. We've got this f of x equals 3x squared plus 5x minus 4. And our denominator is 4x squared minus 2x plus 1. And all we're caring about right now is our end behavior asymptote. So does the numerator have a bigger degree? Are they equal, or does the denominator have a bigger degree? They have equal degree. So their degrees are the same. So same degree. That means we're going to look at the ratio of our leading coefficients. So what is the leading coefficient of our numerator? 3. What is the leading coefficient of our denominator? 4. So our asymptote is going to be where? At 3/4. And what kind is it? Horizontal. This is y equals 3/4. It's really important, as we are going to have not only horizontal asymptotes, but also our vertical asymptotes. We've got to be specific, so make sure you include that y. The y equals 3/4 is our horizontal asymptote. Which means, I guess I'll just put a little sketch up here. That's exactly what I'm going to show you, what this will look like. So our horizontal asymptote would be, for us, at 3/4. I'm just going to say it's probably right about here. This would have a vertical asymptote somewhere, but I'm not going to factor that out and do that. We're just going to pretend it's got one at 0. So if I had an asymptote here, our graph would look kind of like this. So I want us to think about our end behavior. I'm going to make those be a different color because that's kind of gross. There's too much blue. So not domain, but we're going to do end behavior. Those are chunky, but you know what? It's easier to see. So those are chonk-tastic. So think about these ones as x approaches negative infinity. As x gets real small, what is it going to get real close to? It approaches the 3/4. To say f of x is 2.
Oh no, I'm not gonna make you do that. You have to teach us.
I was saying I did, because I'd rather it be pointed over. Someone else pointed it at the table. So it approaches that asymptote. It gets real close to that asymptote, and it's just going to stay there. So when we have a horizontal asymptote, our end behavior winds up at that asymptote. Our f of x is going to approach 3/4. It's very much like when we have limits and they were on the horizontals. It's very similar to that. So the same thing is actually going to happen on the right side. As x approaches positive infinity, my f of x is going to approach what? 3/4. It's the same asymptote. It's just going this way now. So it's just going to get real close to this. And on our end behavior ones, it will never cross them. Okay, so we have a lot of information about our arrows just from that. So we get our asymptote, and it tells us what's happening at the end. When we have functions like this one, we looked at one like this yesterday, where it's not in our p of x over q of x form. What do we need to do to be able to judge these things? How can I make that be something where I could tell which degree is bigger? Yeah, we're going to need to common denominator this guy so that we can make it look more like this guy. So my 4, we're going to need to multiply by what? X plus 2 over x plus 2. To get to that common denominator. We need to be able to see this as one fraction to be able to tell what's going to happen with our asymptotes. So we need to put these back together and put them as common denominator. Ooh. Wonky denominator line, but that's okay. So our denominator is going to wind up as x plus 2, and my numerator is going to be 3x minus 4 times x plus 2. Combining those pieces together. So simplify our numerator. What are we going to get in our numerator?
Okay.
Yeah, you're right. I was just giving a second to think.
Okay.
So our 3x minus 4x, we get minus x. And then we have our minus 4 times 2, minus 8. So we have to put it back into fraction form so that we can figure out what's going on with our asymptotes. Because, yes, dear.
So we multiplied x plus 2 to the numerator and we left the denominator the same.
Mm-hmm.
Why did we bring the negative 4 up there with the x?
Because we're multiplying this fraction times the negative 4.
Oh, okay.
So it's the numerator that gets multiplied. Good question. Okay. So, where do we have bigger degree on the top, same degree, or bigger degree on the bottom? Same degree. So, where is our asymptote going to be?
Y equals negative 1.
I was like, I heard negative 1 and I heard negative 2. What do we think? Our end behavior asymptote. I was going to say, because you were on our horizontal and you were on our vertical. So you're both right. We just need to include that variable because it's different. That makes it different. So our end behavior asymptote.
Oh, after division? The after division thing?
No. She was taking the vertical asymptote, which is when our denominator equals 0. And you were looking at our leading coefficient. That's what I was intending, was for us to look at our end behavior asymptote, our horizontal here.
Y equals negative 1.
Yes. So we're looking at our ratio of our leading coefficients here. So our y equals our negative 1 over 1. So it's negative 1. So as my x goes to negative infinity, what is my function approaching? Negative 1. As it goes to positive infinity, what's it going to approach? Negative 1. It's going to approach the same thing, just from either side. From either side.
And
Okay.
what's the top color?
What's that?
Is that a different sketch?
No, it's the same sketch I had before. It does the same thing. I just didn't put a number on where our vertical asymptote was, or our horizontal asymptote. It was just showing us that as we go out to infinity, it's approaching our asymptote. We'll get into the more details of how we figure out what pieces go where when we do graphing stuff tomorrow. Okay, we need to practice identifying some more of these end behavior asymptotes. We're just focused on the end behavior ones because they're the weirdest ones. All right. So our next one, we have f of x equals x plus 3 over x squared plus 4x minus 2. So, where do we have a bigger degree?
Bottom.
On the bottom. So, you have a couple of options here. You can either memorize the fact, or we can think about the ratio of our leading coefficients when they have the same term. Because how many x squareds does our numerator have? None. So you could write this as 0 x squareds plus x plus 3. So what would our ratio of leading coefficients be on this if we did this like they were equal degree? 0 over 1, which is 0. Or you can think back to our list, memorize the fact that when we have a bigger degree on the bottom, it's always at y equals 0. It's the same thing. So you can either do it as two separate thoughts, or you can do that as one thought. Okay, so it was just one of those, a little bit easier to explain it when we're in here than in that list. So our horizontal asymptote on this one is going to be at y equals 0. So again, you could do it as our ratio of our leading coefficients because I have no x squareds. Or you can remember that when we have a bigger degree on the bottom, it's at y equals 0.
Can
Either
you do
way.
a sketch of this one so we can see what that looks like?
It would look almost the exact same. It would just be that our asymptote is on our axis. So it would be Let's pretend it's got a vertical asymptote over here this time. It would be right here at our x-axis. Like that. So our asymptote would be the x-axis. The vertical asymptotes can be anywhere. The horizontal asymptotes can be lots of places.
And does it matter the sides that we're on?
When we get into the graphing,
Okay.
yes, it will. But at this point, until we do all of the pieces together, like our x-intercepts, our y-intercepts, our discontinuities, our horizontal asymptotes, our vertical asymptotes, we need all those pieces to make the graph. So I'm just tossing these sketches up to give us an idea of what's happening as opposed to just going, it did a thing. Awesome. I don't know what that thing is. So I'm just trying to give you guys a little bit of context so that it's less magic. Because sometimes when we do things in here, it feels a little bit like we went, wave a magic wand. It's magic. So I'm trying to make it less magic and more understandable. So the right-hand one over here is almost identical to the one we did on the last slide. It's not exactly the same, but it's almost the same. This is just 3 over x plus 2 instead of 3x over x plus 2. These two. Say it again? It has time behavior. It would just go to 0. Because it's almost the same. The horizontal asymptotes are always going to approach that horizontal asymptote. Yeah. All right. So on this right-hand one, same process as last time. I need to make this be 1 fraction so we can see what's happening with our degrees. So what are we going to multiply the 4 by? X plus 2 over x plus 2. Like I said, almost everything was the same. It's 3 instead of 3x, so it's a different piece. So it's almost the same. So we have, be nice, goodness. So we have 3 minus 4x plus 2 over x plus 2. Which when we simplify this one, what do we get? Negative 4x minus 5 over x plus 2. So do we have a higher degree on the top, on the bottom, or are they equal? They're equal. So how do I find my asymptote? The ratio of our leading coefficients. So where is my horizontal asymptote going to be? Negative 4. It's these leading coefficients right here. So my 4 and my 1, or my negative 4 and my 1. So y equals negative 4 over 1, which is negative 4. So my end behavior would approach that negative 4 on both sides. So when we have the same degree and when we have the bottom having the bigger degree, they're not awful. They're not awful. There's a lot of pieces, but they're not awful. We have one more type of asymptote to look at that we haven't seen yet.
Look at all?
Yeah, because we got to do our obliques. All right. So we've got one more type of asymptote we have to look at. We haven't seen a slant one yet. So if it has a higher degree on the top, like the book sometimes calls them top heavy and bottom heavy versus like equal because choices. For reasons unknown, probably written by man. But what we're going to do is we're going to divide the two pieces. I'm going to take my numerator and divide it by my denominator. So you can use long division if you prefer it. I recommend synthetic. It's usually shorter and faster. So we're going to take our numerator, and I'm going to set up our synthetic division right here. What are our coefficients for our numerator here? 1, 1, 3. And what is our root going to be that we're dividing by? Negative 2. So then we're going to do our synthetic division. Our 1 drops. 1 times negative 2 is negative 2. Add them together, we get negative 1, positive 2, and we get a remainder of 5. So what is the polynomial down here going to be? What would this be if we wrote this out? 1x minus 1. The 5 is irrelevant. We ignore the 5.
It's just the remainder, right?
It's the remainder of what we did here and has no impact on what we do with our graph at all. Our 1x minus 1, or x minus 1, that will be our asymptote. It's a line.
Oh.
So when we do the graph, which I'm going to give us a little sketch of it on here. There's a little space here. This is a line. How would I graph that line? Where would I start? Negative 1. Up 1 over 1. So it would give us a line like this. It's an asymptote, so we're going to use a dotted line. Ooh. See if I can draw a straight line. I'm trash at straight lines, y'all. Oh my gosh. Where would this one have its vertical asymptote? It's going to be where our denominator equals 0, which is going to be the factor that we divide by, which is going to be our negative 2. So I'm going to put that over here. So there's going to be a couple of places we can have these lines and what they're going to look like. I'm just going to sketch a couple of them so we can see them. I'm going to make the pen be a little less obnoxiously chonky this time. It could be that it looks like this. We're not crossing our asymptotes, but we're approaching. So that's one option for how our function looks. Or it could be in our other sections. It could be down here and up like this, and up here and like this.
Well, that's what I was confused about earlier, like on the first problem, which side do we choose? And when we're graphing, it'll tell us which
We will put on like our x-intercepts, our y-intercepts, and those kinds of things will help us figure out where our points are going to be. But so either way, it's going to look like this. And our end behavior as we go out to positive and negative infinity is going to be the same end behavior of the line, of the asymptote. So the end behavior of our function will be the same end behavior as that guy. That is a line with a positive slope. So what's its end behavior? As x goes to positive infinity, which way does the function go? As it goes out to positive infinity?
Oh, infinity.
Positive infinity.
I thought we were supposed to start with as x approaches negative infinity first.
You can do it in either order. We traditionally do start with negative infinity, but I also like to, sometimes throw wrenches at you guys to make you think. And as x approaches negative infinity, which one does this go to? Negative infinity. So it's the same end behavior as that line. Okay? And again, we will work more with these when we get into the graphing stuff tomorrow, but these are all the pieces we need to be able to put together the graphs. So we'll find asymptotes, intercepts, discontinuities if we have them, and we're going to get graphs. We will do graphs tomorrow after the quiz. So you guys have about 8 minutes. Okay, sorry, 7 minutes. It just switched. Where you can look at stuff. If you got questions on the review, you can ask them. If you got questions on the homework, the quiz is tomorrow. And I do have the answer key for the review posted up on Canvas.
And the quiz is over 4-3.
4-3 and 4-4. It is not any of these pieces.
Oh, okay.
It is the polynomials, the finding all solutions, and the putting it in factor form. Just you. Yep. So this guy here, yes. 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 Yep. Just like that.